This is an introduction to the components that you have in your kit for lab number 2. First thing that you'll see is the little Arduino Nano microcontroller. You'll see that it has pins on either side of the microcontroller, and you can see them on either side of the edge. These are the pins that we're going to be mostly working with. It also has a communication port so that it can hook up to your computer via USB. Right here in the middle is the chip. That's the microcontroller chip. All the rest of the stuff is just LEDs that kind of give you an indication of what's happening. And we can also actually control one of these LEDs. It's this 13th pin LED right here. We'll be able to use that to blink and to give us some readout. We can program and make this LED do what we want. Other than that, the things that we're going to be looking at, so this power supply comes from the USB. It comes from your computer. The other important things that we're going to look at are the connectors for the digital in and out connections. So they're found over here on this side. You can see that they're labeled, well, D2, 3, 4, 5, etc. Right here is the ground pin, so we'll need that ground pin, or we can also use the ground pin over here. And we can also use a 5-volt supply pin, but we're going to use the digital pins for our 5-volt supply. These digital pins give either a high or low signal. High is a 5-volt value, low is 0 volts. And that's how we can either use them as outputs by giving a signal or as inputs by receiving a signal. So, and it's only the on or off, or the high or low signal that those receive or give. Then we have the analog pins over here on this side. Those can receive varying values between 0 to 5 volts, but analog meaning that it can take a range of values between that high and that low value. So those are the ones that we're going to worry about. So the digital pins, the analog pins, and the ground pin, and then you'll need to notice where this LED 13, pin 13 LED is. We'll be controlling that. In your kit, you also have a red, green, blue, or RGB LED. Basically, this is a 3-in-1 LED. We have inside this little housing here, there are actually 3 LEDs, a red one, a green one, and a blue one. And we can control them separately because they have separate leads shown here. They all have a common cathode. So this cathode will lead to the ground, but will supply positive voltage to the red, green, and the blue pins, and we can control those separately. We can also mix the intensities of those colors to get basically any color that we want. This is similar to how an LED TV works, by mixing the values sent to each LED pixel to give whatever color we want. So like I said, the cathode is common to all of them, and it will be connected to the ground. Important with LEDs and with most circuits are having resistors. So you have 4 resistors in your kit as well. These are fixed resistors, and they're used for limiting current in a circuit. We are going to use these resistors to make sure that our LED doesn't blow up, because it can only have a certain amount of current going through it, and we're also going to use it to help make a signal readable by the Arduino. So these 3 right here, the 430 ohm resistors, you've got 2 of those, and the single 470 ohm resistor, those we're going to use to help us with the Arduino, and this larger 10k ohm resistor, it's going to help us make what's called a voltage divider, so that we can read a signal from one of our sensors. The way that we read resistors is by this kind of color code. This is a table to help you see what value the resistor is. So for example, in here we have, in your kit, you have all 5 banded resistors. So the first three bands give you a value for the resistance, and then the fourth band is a multiplier. So for example, this one, we have a red, orange, purple, so we take a look and we find red on the first, that gives us 2, and orange gives us 3, and then purple gives us 7, and then black is a 1 times multiplier, a 1x multiplier. That means we have a 237 ohm resistor. So if we go back and we take a look here for our 430 ohm resistor, we've got yellow, orange, black, black. So if we go back over here, we see yellow gives us 4, orange gives us 3, black gives us 0, so 430, and then we multiply by 1, so that's 430 ohm. And you can check the other resistor values to make sure that we have that right. The last band gives the tolerance, so how, within what specification will it be that resistance. So this resistor here is guaranteed to be 237 ohms plus or minus 1% of that. So the smaller the tolerance, the tighter the range that we can count on that resistor having that resistance. You also have a photoresistor. This resistor has a resistance that changes depending on the light that it is receiving. So for it will have a certain resistance when there's no light on it, and then once light hits it, its resistance drops. So if I were to switch on a light, the resistance would kind of look like this. It would be high at some value, and then it would drop to another value that would be lower. The more light that is hitting that resistor, the lower the resulting resistance will be. So that can be useful for a sensor. You also have a passive infrared motion sensor, so PIR motion sensor, and this is going to detect an object that's emitting IR radiation that's moving. So it can detect IR radiation, and it can see when that radiation is moving from one position to another. So it's going to help us be able to sense motion. It is hooked up using these 3 pins right here. We'll put connect ground to this pin. We'll connect a positive 5-volt supply to this pin, and then this output will connect to one of those analog pins on the Arduino so that we can get a value, because it's going to output a resulting voltage between 0 and 5 depending on what it senses. The other things are sensitivity that we can change. We can adjust its time delay. This one's a little bit more complex of a sensor than our photoresistor, and it also has different modes that we can use to trigger. We'll talk about those as we implement using this sensor. So the top side looks kind of like this white golf ball, and then the bottom side is the guts of the sensor. So you can see that there. You also have a breadboard. This is very useful for connecting wires when we are experimenting to make sure that things are working correctly before we solder anything permanently in place. The way that a breadboard works is it has lots of different holes. They're arranged in rows and columns. You can see the rows and the columns here in the picture, but then here's sort of a schematic of the rows and the columns. And then a split down the middle of the breadboard. But each of the outer columns, you can see that these circles or those little pins are connected. That means that those are connected essentially like there are one wire. So if I connect something into this pin and I connect something into a pin over here, I've essentially wired those two things together. So that helps me connect up circuits. In addition to the columns, there are rows near the middle, and each of those rows are connected as if they are connected by a wire. So if I put something in this part of this row, this pin in this row, and I connect something anywhere along the row, say in this pin, it's as if I've connected those two components by a wire. So that's what breadboards do. They're going to help us create a circuit without having to do any soldering. So we can prototype and test. In addition, and the last things that you have in your kit are several cables that are going to help, or wires and cables that are going to help us connect everything together. You have some female to male jumper wires. Those are going to help with the PIR sensor for connection. You have male to male jumper wires. Those are mostly going to be for connecting into your breadboard. And then you have a USB-A to USB Mini B cable, and that's going to be how you connect your computer via USB to your Arduino via USB-B. So that is what you've got for your kit.